Okay, so Junior Roberts here, coming to you with realjuniorroberts.com. And in this video, we'll be looking at an introduction to physical quantities. So let's go right into it. Okay, so first of all, let's quickly discuss our learning objectives. So at the end of this lesson, you will be able to define the term physical quantity as it relates to the study of physics. You'll also be able to list the 5 base/fundamental quantities, and you will also be able to recall that physical quantities can be divided into base quantities and derived quantities. So let's go right into it. Okay, so the first thing we're going to ask ourselves is, what are physical quantities? So when we think of the term physical quantity in physics, right, we're looking at those things, right, which we can measure, right, and once we are able to measure those things, we are able to express them using a number with an associated unit. So therefore what we're saying is that physical quantities are things which we can measure and are expressed using a number with an associated unit, right? And here I have an example of what we can consider as a physical quantity, right? And we'll consider this as a physical quantity by the mere fact that we can measure its value, right? So we can measure the age of someone. In this case, right, we will represent or will express the age of someone as 14 years. So we have our number and we have its associated unit. So again, what we have here is the age being our physical quantity, right, 14 being the number, right, and the unit being years, right? So that's an example of a physical quantity. Now here are some other things that we can also consider as physical quantities, right? So the first thing we're going to talk about is the volume of soda in a can, right? So we can measure the volume of soda in a can, and when we measure that volume, we can express it as a number with an associated unit. Another example might be the mass of a tennis ball, right? Another example, the electric current flowing in a wire. So all these are physical things. So all these are physical quantities which we can measure, and when we measure them, we can actually express them as a number, right, with an associated unit, right? So now we're saying here that physical quantities can be divided into 2 categories. So we have our base or fundamental quantities, and we have our derived quantities, and we'll be actually looking at the definitions of these two shortly. So again, our 2 categories of physical quantities include our base quantities, which are our fundamental quantities, and our derived quantities. So now when we consider base quantities, right, we say that these are the basic or fundamental quantities from which all other physical quantities are derived. So what we're saying is that our base quantity, these are our fundamental quantities, right, and from our base or fundamental quantities we can actually derive other physical quantities, right? So now we will now look at the 5 base quantities which we will need to know. So the 5 base quantities that we need to know are mass, length, time, temperature, and electric current, right? So for our purposes, we will be interested in these 5 base quantities. However, there are an additional 2 base quantities which we're not going to be concerned about, but just to make you be aware, we will list them here as the amount of substance and luminous intensity as our additional 2 base quantities. But again, for our purpose, we're going to focus on mass, length, time, temperature, and electric current as our base quantities. So now We will now quickly look at derived quantities. So derived quantities are physical quantities that are formed from the multiplication and or division of base quantities, right? So in order for us to actually get a derived quantity, we have to quote unquote derive it from our base quantity, and we do so by either multiplying or dividing our base quantities, right? And even though we have only 5, or I should say even though we have only 7, but again we're only going to be focusing on 5, even though we have a limited amount of base quantities, we can have many derived quantities, right? So all physical quantities, right, whether it's a base quantity or a derived quantity, will have an associated unit, right? And we call that unit its SI unit, right? Now all SI units of physical quantities are governed by the SI system of units, right? So all units that we will ever use to represent our physical quantities will actually come from that SI system of units. Some physical quantities can be measured directly, right, while some will require the use of mathematical formulas to obtain their value. Now let us say, for instance, we take an unknown substance X, right, and we measure its mass and volume, right, which are physical quantities, and we measure those directly, right? Now if we apply a mathematical formula, we can actually obtain the density of that substance X, right? And the density is another physical quantity, right, which in this case is a derived quantity, because we would have formed it in this case by the division of our two quantities, which are mass and volume. So mass is a base quantity, volume is a derived quantity, but when we actually divide mass and volume, we're able to actually obtain another derived quantity, in this case density. Now we will see that throughout our study of physics, we'll be using a lot of mathematical principles quite often, right? So we can now appreciate the fact that mathematics is the language of science. So we're just going to quickly wrap up what we would have discussed so far. So what we've learned so far is that physics is the study of matter and energy, right? Now matter and energy are what are considered as physical quantities. So we could actually say that physics is a study of physical quantities. Now, a physical quantity are those things that we can measure and can be expressed as a value with an associated unit. Physical quantities can be a base quantity or a derived quantity. And studying physics relies heavily on the use of certain mathematical principles, right? And these mathematical principles will make our lives as physicists much easier, right? So this was Junior Roberts with realjuniorroberts.com. If there was anything in this video that you wish to get further clarification on, please post them below in comments, and I'll do my best to clear up any misconceptions for you. If you're studying physics and you find that you're struggling to understand certain topics, then sign up for my live interactive CSEC physics classes. Full details will be posted below in the description. Like this video if it was helpful, and thank you for watching.